Okay guys, the next unit of measurement that we need to talk about is mass. And to measure mass in the scientific classroom, we usually use one of these tools, which is a triple beam balance. You may have learned about triple beam balances last year in science, so this might be a little bit of review for you, or it might be some new stuff. So triple beam balances measure in grams. That is the unit that they use. Not sure if you're going to be able to see it when we're this zoomed out. We'll take a closer look later, but it tells us right here that we measure in grams. There's a little G right here which tells us our unit, okay? And just to be clear, we are measuring mass, M-A-S-S, mass, with a triple beam balance. All right, so let's talk a little bit about the balance first. So first off, it's called a triple beam balance because it has these three beams which we move these weights across in order to balance out whatever weight we put on this side with the weight that is displayed on the beams. So it is a triple beam balance because we're balancing things. Okay, so name makes a lot of sense. So let's talk about how you use one of these things. By the way, actually, before we talk about that, a balance is different from a scale. A lot of people mix those up. A scale measures weight and a balance measures mass. Okay, the difference between those things is that a scale, so like a scale that we might have in our bathroom that we measure our weight with, how many pounds we are, okay, that's different from grams, okay, because weight takes into consideration how gravity is affecting it. If you stood on a bathroom scale on Earth and you stood on that same bathroom scale on the moon, it's going to give two different readings because the Earth and the moon have two different gravities. But if you took this scale to the moon, if you measured something here on Earth and you measured something on the moon, it would give you the same reading because the mass doesn't change. Gravity changes. Gravity doesn't matter because gravity is pulling down on this just as hard as it's pulling down on this, okay? So balances are not affected by gravity. Scales are affected by gravity. So this is a balance, not a scale. So yeah, let's go ahead and talk about how we use one. So I might be moving the camera around a little bit here to get you better views of things, but a couple things we need to do before we put anything on here to measure. The first thing we need to do is make sure that this is clean. Sometimes in the science lab there might be drips of water on it or dust or whatever, so we want to make sure our plate is clean. That's where we're putting whatever we want to measure, so we want to be sure it's as clean as possible so we get a nice accurate measurement. The next thing we need to do is take a look at our weights. By the way, let's zoom this in a little bit if I can, which means I just got to move my whole camera here. We've got three different sets of weights here. Okay, this middle one is the biggest one. That's our hundreds place. You can see 0, 100, 200, 300, and so on. In the back, we've got our tens place weight. So this guy, oops, I'm grabbing the wrong weight there. This guy slides around, and that will measure our tens place. And then up front we have our ones place weight. And this one's tiny. You'll notice too, these guys have grooves. We'll talk more about those in a minute. So the back two have grooves. The ones place just freely slides. We'll talk more about that in a minute. So we've made sure our plate is clean. The next thing we need to do is make sure that all of our weights are set to the 0 position. So I don't know how well the camera can show it, but these weights, actually let me pause this for a second. Okay, I colored in these little arrows, so hopefully you can see them a little bit better here on camera. So anyways, these little arrows point at the number that it's reading. So this one's reading 0 here, which is good, that's what we want. This one's reading 0. And because these have grooves, you'll notice that I'm kind of shaking them. And that's to make sure, sometimes they can sit a little bit out of a groove, so it kind of looks like it's pointing at the 0, but it's not quite in the groove. We want to push it down. You maybe heard it click, and if I kind of push down and wiggle, it shouldn't move because it's sitting in the groove. So to show it on this one, it kind of looks like it's on 0, right? But if I wiggle it, it'll move. There, it's in the groove. Now it's not going anywhere. So we've made sure that all of our weights are set to 0. And the last thing we want to check then, when nothing is on the scale and nothing and all the weights are set to 0, we want to make sure that, make sure the camera can see it decently well, that these lines line up. There we go. Now the camera is a little bit at a funny angle right now. Hopefully that'll stay focused there. I don't know. Doing my best here. There we go. That helps. So the camera is a little bit at a funny angle, so it looks maybe a little bit not lined up. I'll try to set the camera a little bit straighter. Thing is, if I set the camera straight, you can't see this. So just take my word for it. They're lined up. Okay? So we're all lined up, which means we're ready to measure. Okay? So I'm going to adjust the camera and then I'm going to get to measuring. Okay, so right now you guys don't have a very good view of the little 0 line, but that's okay. I want you to focus more on what's going on here, and we'll kind of talk about what's going on the 0 line. So nothing's on the scale right now. We're going to start out by weighing the book that we, well, not weighing really, we're going to mass the book that we measured before. Remember, we measured side to side. Now we're going to measure the mass of this book. So all I'm going to do is place it on the scale. Now you'll notice when I place the book over here on the scale, the arm over here moves upward, right? It goes up to the top. Our goal is going to be to balance these, move these weights around until this arm goes back to the 0 position. So we need to slide some weight over this direction in order to balance it out. Now there's a certain order in which we want to do that. Sometimes students like to just start moving things around like crazy. It doesn't work that way. We have to be methodical and careful about it. We always start with the biggest weight first, because this is going to make the biggest difference, and then we work our way down to the smallest weight, which is going to help us balance out just a tiny little bit. So, starting with the hundreds place weight. What I'm going to do is, now remember I mentioned those grooves before. Those grooves are really important. If the weight isn't sitting in those grooves, it's not going to give you a good reading. So I'm going to pick up my weight from the 0 position. I'm going to start kind of starting to move it. And I'm going to push down gently, and I'm going to slide it to the side, and you'll hear it pop into place. Okay, right there. So it kind of snapped, and the arrow is pointed directly at the 100, which means there is 100 grams. Here's our little letters over here, grams. There's 100 grams of weight on this side, but the book is still weighing more. This arm is still to the top, so we still need to move more weight this direction. So we're going to keep moving with the 100. I'm going to keep going, pick it up, slide it down, slide it into that next groove. Now see how my arm went down, okay? It had been, when we were at 100, it was still up at the top. And now at 100, 200, it goes down. Sorry, I just had another teacher walk through my room there. So now we're at 200, it moved down, which means when that arm moves down, we actually need to back this off 1 to send that back up. Then we're going to move to the 10s, and we're going to do the same thing. We're going to slide it to the next slot. Arm is still up, so we still need to keep moving. Slide it to the next slot. Arm is still up, so we still need to keep going. Slide it to the next slot. Arm is still up, so we still need to keep moving, but it's getting closer. You can see it's not so unbalanced now. Move it to the 40. Okay, now when we're at 40 grams on that beam, the arm moves down, which means that's too much weight. We need to back it off 1. Okay, so the final beam that we need to work in is this 1's place, the one up front. And what I'm going to do, I like to use a pen. I find that my fingers are kind of clumsy. If I try sliding around with my finger, it doesn't work as well. So what I'm going to do is use the tip of my pen and just slide this slowly. And as I slide, I'm going to watch this arm over here and wait until these 2 lines line up. Like I said, your perspective is not the best. We really should be viewing it straight on. Okay, I think that that's pretty close. So I'm going to move the camera a little bit so that you can see that these are lined up, and then we're going to take our reading. Okay, so let's start by seeing if I can show you how those lines are lined up. When we view them straight on, they're pretty well lined up, or at least close enough for us. And let's talk about how we take our readings on this. Make sure I'm adjusted decently well. Okay, that should work. So, when we're doing our readings on this, slide that to there. We have essentially 4 numbers that we need to fill in. First off is the hundreds, tens, and ones place. So the hundreds is on the middle beam, tens is on the back beam, and ones is on the front beam. But this ones beam also has 10th divisions. So that's where I get this 4th number from. So once we get to here, we're not just going to read 1 gram, 2 grams, 3 grams. It's going to be 2 point something. I can tell already that our little arrow here is between the 2 and the 3. So it's going to be something 2 point something, okay? So let's talk about how we read the numbers off of the balance. It's really pretty simple once you get the hang of it. Always remember that we start at the middle one, the biggest one. So because our hundreds weight is at the 100, our hundreds place is going to be 1. Our tens place weight is on the 30, so our tens number is going to be a 3 for 30. For ones, let's zoom into that. Okay, so for our ones place reading, this would be 1 grams, 2 grams, 3 grams. We're somewhere in between the 2 and the 3. So it's going to be 2 point something. So I will write down in my ones place right here, I'm going to put a 2. And we just got to figure out what that tenths place is. So we just got to count these little tick marks, right? So there will be 2.1, 2.2, 2.3, 0.4, 0.5, 0.6, and 0.7. It's kind of in between the 0.6 and the 0.7, but I think it's a little bit closer to 0.7. So let's go ahead and decide 2.7. So that's all we have to do, is decide the nearest whole number rounding down, and then count the little tick marks, 2.7. So that means in total, our book has a mass of 132.7 grams. And again, grams, we know that we are measuring in grams because that's what all of these weights over here tell us, okay? Let's try a couple more objects, and then I will let you get started with your work for today. Okay, and actually I left all this on here because I forgot one important thing. When you're done taking the mass of a thing, like our book, you really, the best etiquette, the nicest thing to do, the thing that I, in my lab, always have my students do, is when you're done measuring your thing, put it off to the side and return everything to 0, okay? Make sure everything is on 0 so that it's all ready to go for the next person, okay? Next thing we're going to measure is a pair of scissors. So everything is on 0, doing my checks, everything is on 0. This still lines up nicely with the 0, and this plate over here is clean. So I'm going to put my scissors on it. All right, and we're going to start again with the hundreds place weight. I'm going to slide it down into the next groove, and we can see already that arm has dropped. So 100 grams is too much. So I'm going to go ahead and back it off 1. So we're back at 0. We know now that these scissors are less than 100 grams. We're going to start with our tens place then. Slide that down into the next groove. Arm is still up, so we'll keep going. Next groove, arm is still up. Next groove, arm is still up. Next groove, arm went down. So that means we need to back this off by 1 groove. So the arm moves back up. Finally, I'm going to take my pen and start sliding my ones place weight down until I see these lines line up. sure it's not stuck. It's not. Okay, so that was too much because it went a little bit too far down. So I'm going to back it off this direction. And go a little bit more. Okay, I think that's pretty well lined up. So, taking our measurement, make sure you guys get a good angle. Okay, our hundreds place has nothing, so we don't have a hundreds place. We only have tens, ones, and tenths, okay? So we have 30, and then looking down here, it's between the 6 and the 7, so it's 36 point something. So 36 point something. We just got to figure out what that something is. And if we look real close, hopefully you guys can see it well enough on the video. Looks like 6.123. I think it's on the third little line there. So 36.3 grams is our mass of the scissors. Okay. Let's do a couple more objects here just to keep going through that process and also to show off some of my stuff. So slide everything back down to 0. This lines up with 0 again, so we're good. Next thing I want to take the mass of. If you guys had Mr. Wicker last year, you might recognize this man. Mr. Wicker and I have been friends for a while. We knew each other when we were in middle school, so we had school pictures taken one time, and we didn't know what to do with our school pictures because, like, we're not going to go home and put them on our own refrigerators, so we just decided to stick them on action figures and have each other hang out in our rooms as moral support. So we're going to take the mass of my Mr. Wicker action figure. Starting with the hundreds weight, slide it down one. Whoop, that was already too much. So again, that was too much. Arm moved down, we're gonna slide it back one, which means the mass of this action figure is less than 100 grams. All right, starting back with the tens place, move it down one, not enough. Move it down another one, still not enough. Keep going, not enough. Keep going, almost, and boom, it went down, so we're gonna back off one. Came back up, now we need to slide this guy down. Starting to level out. And we'll say that's pretty good. So taking a look at that reading. Again, nothing in the hundreds place, but we have a 50 in the tens place. So let's grab a new piece of paper here. So we have 50. And then our ones place is somewhere between the 1 and the 2. So it's gonna be 51 point something. And I see 1, 2, 3, 4, 5, 6 little lines. So 51.6 grams will be the mass of our action figure. Okay, one last measurement and we will be done. I want to show you how small of a thing we can take the mass of on here. So set everything back to 0, make sure that lines back up to 0 again. And we're going to do a paper clip, so just a regular paper clip and see how it moved. Now, I can already tell you it's going to be less than 100 grams. If the scissors and the action figure were less than 100 grams, this paper clip is going to be less than 100 grams. It's probably going to be less than 10 grams even, but we're going to check anyway. Yep, arm went down, so we're going to back it off. So we're somewhere in the just single digit range here. So we're going to slide this down. We're even less than 1 gram on the paper clip. We'll call it there. So that paper clip, let's move the camera a little bit here. That paper clip is 0 hundreds, 0 tens, and it barely made it to a 1. I'm going to say that's not even 1. That's going to be 0.9 grams. 0.9 grams. So that is going to be our measurement. Sorry, I got some notes up there. 0.9 grams is going to be the mass of our paper clip. Okay, so hopefully this is a good refresher or introduction to the triple beam balance. You're going to have some work to do with this. If you have any questions, sorry, the camera's moving around, trying to make it a good view of the triple beam balance in the end here. If you have any questions on how to use this or anything at all, the reading of it is kind of the main thing that we're going to be focusing on, is how you read the measurement on the balance, okay? If you have any questions at any time, please let me know.